Yeah, talking about LTE operation and unlicensed spectrum, I was down in, was it Dallas last year, Keith, for WLPC? Yeah. So down in Dallas and did a little presentation, and it's actually quite amazing what's changed between January and now. In the first place, or maybe that was February, but in the space of 6 months, a lot has changed. And I remember the reaction that I got a lot of from the attendees was, you know, just don't do it. We shouldn't be doing this, da da da. I said then, the ship has sailed. It has sailed. You've been following what's going on in the trade press. You know, lots of talk about LTE-U here in the States, lots of talk about LAA and LWA within 3GPP. So these things are happening, are continuing, so we all really ought to be paying attention to them, and that's my objective here this afternoon. So there are many different proposals or many different programs to do LTE operation in unlicensed spectrum. These are the three major programs at this point in time. There is one other flavor that I don't have listed up here, which would be the multi-fire or MU-LTE fire program that really at this point is essentially a blog post and some marketing announcements, but there's not a lot of technical details on it. Multi-fire was announced in early June, and it's basically a proposal to do LTE fully in unlicensed spectrum. All of these programs require some amount of licensed spectrum in order to deploy. So important to note at the top, really all of these programs are about achieving the same goal. So what we're trying to do here is boost aggregate LTE data throughput by augmenting licensed spectrum with unlicensed spectrum. So the question then becomes, you know, what are the distinctions between these? And we've got LTE-U, LAA, LWA. Biggest thing right off the bat, LTE-U is not a 3GPP program, right? So the far left, you'll see I've got my nice color traffic light system here. We've got red, yellow, and green. Should give you some indication about sort of our position on the technologies. LTE-U is not happening within 3GPP. It's happening, or it's being driven by a group called the LTE-U Forum, which is a few technology companies, a few cellular infrastructure vendors, and then a couple of mobile operators. 3GPP, global organization, hundreds if not thousands of members, has been driving cellular standards since the late 90s, and that's where the LA and LWA programs are coming through. So much broader support. And I would also say now with LA and LWA, and I'll talk about it a little bit more, you're starting to see greater coordination between 3GPP and the Wi-Fi industry, specifically IEEE, WFA, WBA, such that Wi-Fi coexistence is definitely being taken into consideration with LA and LWA. So a little bit more concerns about the potential effects with LTE-U. I'll talk about why we feel that way. For coexistence, it's using a mechanism called CSAT, which stands for Carrier Sense Adaptive Transmission. At a very high level, we're really talking about the UNI 1 and UNI 3 channels. That's what LTE-U and LAA are definitely targeting. So with CSAT, a LTE-U small cell would come on station, do some detection to see what sort of activity there are on the channels. If it can find an open channel, it would set up there, and obviously coexistence wouldn't be an issue. Can't find an open channel, CSAT will try to find the least loaded channel and then make a determination about what activity or what percentage of the airtime is being utilized. And then CSAT makes a determination about what percent of the airtime should be allocated for LTE-U and what percent for Wi-Fi. So if it was to assume, or if it was to make a determination that 50% of the channel should be LTE-U, 50% Wi-Fi, it then does a duty cycle approach, carves up the airtime into time slices. Those can be up to 50 milliseconds is my current understanding of the LTE-U forum spec. So if we're using 50 millisecond slices, LTE-U would come on net, take the channel for 50 milliseconds. Wi-Fi energy detect is going to be tripped. Nobody's going to be able to do much. And then at the end of the 50 milliseconds, Wi-Fi gets its turn. And that's sort of the premise of LTE-U. And there are some holes that are going to poke in the LTE-U duty cycle with these almost blank subframes, try and support things like voice over IP. We have concerns about LTE-U.
You mentioned channel. Does it follow the same 20, 40s, 80s, same locations? Or are they going to play with different channel
everything that I have seen is that it's looking at 20 meg channels. It doesn't necessarily follow the the same aggregation that we're doing with AC. So I know that one of the tests that I saw actually out of Korea was a 60 megahertz use in Uni 3. So they grabbed, yeah. But, right, so it is essentially the same 20 meg chunks.
And just for clarification, so LTE-U is the one that's Ericsson, Qualcomm,
Ericsson, Verizon. ALU, I believe, Nokia. I'm trying to remember off the top of my. If you go to ltuforum.org, you should see the companies.
My Wi-Fi is not working. So I was trying to look it up on my phone, and then LAA is T-Mobile, right? Or no, it's T-Mobile part of LTE-U.
Everybody who's doing LTE-U is also doing LAA. Yeah. So I mean, that's an interesting point. So basically all the LTE-U forum members driving the LTE-U program are also participating very actively in the LAA development, and I would say most of them are also supporting LWA development. So they're not mutually exclusive; they actually overlap. So the thing about LTE-U is it's only applicable to the areas of the world where listen before talk is not required, right? So the U.S., Korea, China, markets like that. Over in Europe, one of the things about, and we'll talk about LAA and some of the stuff that's going on with Listen Before Talk and LAA, they're really looking to adopt the European ETSI brand LBT requirements because in Europe, in 5 gigahertz, you have to do Listen Before Talk. I'm sorry, there's another question.
Are these competing proposals, or are they all just going to be implemented at the same time, kind of thing?
Okay, so there's two questions there. Are they competing proposals? They're different ways of accomplishing the same goal. So I mean, I guess I'll leave it to you to determine whether that means they're competing or not. We feel that, I mean, the most competition I would say is between LTE-U and LAA, and I'll get into some of the distinctions maybe on the next couple of slides on that. LWA is really a different way of skinning the cat because instead of doing, okay, so I am getting ahead of my slides, but actually, can you hold, Chris, do you mind if I come back to that in a couple slides? Because I think in the interest of time I should move. So non-3GPP, non-standard program uses the CSAT for coexistence with Wi-Fi, only applicable to the US, Korea, China. LAA, global standard, will do a listen before talk. Looks like it'll be based on the European ETSI brand standards. And then LWA, really a different way to do this. So with LTE-U and LAA, we're talking about bringing the LTE PHY and MAC into 5 gig. With LWA, we're talking about tunneling LTE data over Wi-Fi and using 802.11 as the channel access. So a much different approach. So I think maybe this will answer a few questions. So I wanted to move on to this slide. So this is a sort of high-level representation of what LTE-U or LAA would look like. Again, the distinction between them is going to be how they're coexisting with Wi-Fi, as we talked about, whether it's CSAT or whether it's actually a listen before talk approach. So you've got a LTE node B. Basically, these presuppose indoor small cells. They're really developing these programs for indoors and for small cell technologies, obviously, so you've got sort of the same coverage and power and things like that, or close to. Actually, there's some nuances around power levels. You've got standard interfaces from the LTE radio access network, the eNode B, back to the mobile core. So this is a 4G evolved packet core up at the top. And that's actually quite important to the mobile operators. There's been ways they could integrate Wi-Fi into their mobile cores, but they've always involved translations and gateways and things like that, which has been a little bit challenging for the mobile operators. So now, with all of these proposals, the integration is done at the RAN level, and the interfaces back to their core are standard to them, so S1, S1A. Yes, Sam?
Does the integration back into the mobile core, is that required, or are we seeing the burgeoning of a technology that we as enterprise admins can maybe leverage for clients? I mean, if we fast forward 5-10 years, are we going to see LTE-U adapters replace Wi-Fi adapters, and then we're going to be hanging LTE-U APs that terminate on our enterprise route switch network?
Right. Well, that's a really good question. And I would say the issue today with that sort of approach is the access to the spectrum, right? And the fact that, right now, all these proposals that we're talking about, again, require this licensed spectrum anchor. So over here on the blue side, right, you've got your control, your uplink channels, your paging channels, this is all LTE stuff. So LTE control, uplink, primary downlink, all of that's happening on this license link, right?
License link, okay.
So the only ones who have that today are the mobile operators who've paid, the government for it. There's some interesting things going on with 3.5 gigahertz, which I hope to talk about, which might enable sort of the scenario you were talking about for sort of private corporate use of LTE in the future.
LTE, yeah. Okay.
So yeah, good distinction. We got a licensed anchor here, the blue Airlink. That's the LTE Airlink. And then we've got this red Airlink, which is an unlicensed 5 gig. And that is where we're doing essentially, it's called a secondary cell. So this is a downlink only secondary cell. And it's using what's called carrier aggregation. So that's an existing LTE release 10 through 12 spec, basically where you can bond downlink channels.
So if you're an enterprise, say enterprise healthcare organization in a 10-story building and you're down in the basement and you don't have LTE coverage anyway, you're not going to be bothered by the LTE conversation anyway, right? Because you don't have the anchor frequency.
Absent LTE coverage, there is no LTE-U.
There's no LTE-U.
Correct. That's where I was saying it really presupposes deployments of indoor licensed small cells.
Okay.
Yeah. So LTE-U, LAA, distinction again is the coexistence CSAT or LBT. LTE-U is specifically downlink only, and at this point there are no plans to implement uplink in unlicensed. With the LAA, which is again the 3GPP version of this with listen before talk, release 13, which is basically going to be finalized in the March 2016 timeframe. So this is LTE release 13. It will be downlink only, but they certainly have it on the roadmap to use it for uplink in future releases, so probably release 14 is when we'll see uplink with LAA. So, has anybody heard this LTE-U is a better neighbor to Wi-Fi than Wi-Fi? Yeah. So,
Not from anyone in Wi-Fi.
not from anyone in Wi-Fi, but you've probably heard this. So, right. So I just wanted to, it's important that you as Wi-Fi professionals understand sort of what is the basis for that statement, right? So a long paragraph I found on, I think this was on the Cable Lab site. The highlight in blue is what I kind of wanted to draw your attention to. So, we've had 10 billion Wi-Fi devices certified, I think, by the Wi-Fi Alliance over the last, 15, 17 years, however long they've been certifying stuff. And there are some that don't implement the 802.11 standards really well. And so they don't back off the way they're supposed to, they don't do the ED the way they're supposed to, whatnot. And so because of that, because there are bad Wi-Fi neighbors, that becomes the basis for saying LTE-U can be a better neighbor than Wi-Fi because of what I would consider corner case of poor implementations. So that's one basis for the statement. The other is a test that has gotten a lot of play from some people marketing LTE-U, in my opinion. And just, the basis for this test was this sort of Wi-Fi test bed, and then we introduced some LTE-U, and oh look, the performance actually is slightly better when we do the LTE-U inclusion into the test bed. So the test bed was what I would consider sort of consumer grade APs, and they took 9 APs and they paired them with 9 clients, so 9 pairs of an AP with a client, deployed on a single 20 megahertz channel, because that's what we would all do, right? We'd all deploy 9 APs on the same 20 meg channel if we could. Put them in a room, ran some mostly downlink tests, and then they took the 9th pair out and replaced it with an LTE-U Enid B and UE. And the performance of the Wi-Fi actually kind of creeped up a little bit. So, this was actually in January at CES when I first saw the demo. And, GT and Marcus and I and some other people kicked this all around for a while. But I actually just saw this set of tweets from Andrew. I had to get an Andrew mention in, I thought, for his field day. So I just saw these tweets from him on, I think it was Tuesday when I was flying out here. And I just thought this said it very well. It's like, if you design a really poor Wi-Fi environment with about the worst CCI you could come up with, and then you disable RTS and CTS and some other things, and you pump downlink only through it, then when you replace it with LTE-U one set, it actually does look better. So,
Dave, right? You can use curse words to describe this. It's okay now.
Oh, okay. Thank you. So I think the whole neighbor thing. It's like if this was my neighborhood, I'd move. I mean, this should be like Eddie Ferreira's like bad Fi poster child or something. So anyhow. So that's what I want to leave you with about LTE-U. When you hear it's a better neighbor to Wi-Fi, remember why they're saying it's a better neighbor to Wi-Fi. LAA, what I want to leave you with about LAA is, again, it will implement a listen before talk capability or mechanisms. That is almost certainly to be aligned with what ETSI brand requires in Europe. The ETSI brand standard, if you want to look at it, is actually 301.893. And the section that they have for channel access is called adaptability. They refer to it as adaptability. And what I also want to highlight is there's a lot of work going on right now to sort of refine or tighten up the ETSI brand LBT requirements. So there's a meeting coming up in France, a couple weeks from now, brand 84. And at this point, I know of at least 3 different proposals that are going to be offered at ETSI brand for basically to tighten up these LBT requirements. One of the proposals is being sponsored or being co-authored by the companies listed here. So it's actually kind of cool to see, the people that you often probably think of as competing with one another, all cooperating to try to, I would say, represent, Wi-Fi's interests. So, and this is getting into, the proposal is getting into things that, seem pretty basic definitions of what constitutes a busy channel, what constitutes a free channel, ED levels, preamble detection levels, TX ops, slot times, CW min, CW max. I mean, all the things that we think are pretty fundamental to 802.11 operation. We're just trying to make sure those concepts are represented within this spec. So that conversation is happening, and it's worth tracking what comes out of this brand meeting, in my opinion. Looking at the time. Okay, moving on to LWA. So that's about. Oh, I'm sorry, Chris.
Is there any chance a similar kind of restrictions could be enforced as the ETSI brand over here in the US?
Well, the hope is that LAA, the 3GPP program, will require the LBT mechanisms to be used across all geographies, so it would be required globally. And in fact, I believe that's what 3GPP indicated when when IEEE asked them that question in Beijing about a month ago, because there was some question of, will LBT only be required in Europe and places where it's required by mandate, or will LAA as a global spec require LBT? And the answer I believe we got from 3GPP was it's going to be required globally. So anybody who does LAA will do LBT, and we hope it'll be the ETSI brand LBT.
Okay.
Yeah. LWA. So totally different way of skinning the cat and essentially accomplishing the same goals. So looking at the diagram, same mobile core, same sort of initial interface from the mobile core to an eNode B, but now instead of that eNode B implementing an unlicensed radio directly, we're involving Wi-Fi in this process. So I think one of my slides over here makes the point. It actually does, there's co-located and non-co-located modes, so you could put the Wi-Fi radio directly into the eNode B. That's certainly an option. The one that I think is more interesting and conceptually conveys the most information is this non-co-located option, where the Wi-Fi, the WLAN is separate from the LTE RAN, if you will. So sneaking over here. We now have a WLAN infrastructure, we've got an LTE infrastructure, and we're allowing the LTE eNode B to make traffic balancing decisions about traffic that will be sent, again, over the licensed link to the client, and traffic that will be actually forwarded via the WLAN to the client, okay? So how do we do that? Well, we create a new protocol interface between the eNode B and the WLAN, and I say WLAN because this potentially could be, that logical interface could exist at the AP level or it could be at the controller level, right? And we run a what's called XW control and XW-U, which is data. So two different planes, if you will, between the LTE RAN and the WLAN side. The interface on the WLAN side is referred to as the WT interface. If you don't know 3GPP, they love to put alphabet soup labels on all their logical interfaces, so that's just the way this works. And then we have a client down here which supports what's called dual connectivity, so the LTE radio and the Wi-Fi radio are active at the same time, and then it can do a PCP, what's called PDCP aggregation function. So PDCP is sort of the LTE datagram, and the eNode B back up here, as traffic is coming down from the core, again this is going to be downstream in release 13, it's making determinations about what traffic should go over the license link and which should come via Wi-Fi. That can be either done at the packet level, so it could do per packet, or it can be at the bearer level, the LTE bearer. It can send some bearers over licensed and some bearers over Wi-Fi. The stuff that it sends over Wi-Fi comes to us over this XW-U, which is a GTP-like interface. We take it, we put it in an 802.11 frame, we put it out over the wire, client receives it, extracts the PDCP, and reorders it if needed with the stuff that came in on the LT side, and now has essentially a combined.
That's awesome.
So how much client needs?
But-
How much does the client need to be adapted to deal with this?
I just saw a demo this morning. We had one of our partners in doing a demo with our APs. They brought in some clients that are running their chip, and they were showing it to us this morning with existing clients.
Wow.
Well, I can't say specifically which ones they were, but
So,
Yeah.
so is the idea with the non-co-located wireless infrastructure that, let's say I have a Ruckus infrastructure in my enterprise, that my Ruckus infrastructure would actually interface to the LTE device on premise, and now I can exchange data with them without actually having them to deploy wireless infrastructure in my environment? Is that the idea, or is it they're going to be deploying APs along with?
yeah, one of the things that we've heard from enterprises specifically is you're not bringing this LAA or LTE stuff into my enterprise because I've got a mission critical
Yeah.
WLAN here, and nothing's taking my channels for something else. So I think, one of the things I think this opens up is the possibility of you can bring in, if you want to deploy an indoor licensed small cell, that's great. Keep it on, 1.8 or 2.6 or wherever that's operating in the license spectrum. And then if you need to boost your LTE data, you can do it using my WLAN infrastructure on my regular channel plan and whatnot.
And since it's downlink only, does the client actually have to be associated to the wireless network?
Yes.
Client does. Okay.
Yes. So, there's GT's giving me that. I'm getting up and pacing around thing. Oh, okay, all right.
Well, when all your clients are hotspot 2.0, that won't matter, right?
Well, that's
Well, that's actually, I'm glad you went there, Sam, because my other thing I love to talk about. So, that's actually an issue right now. I can tell you that what 3GPP is looking at, I probably won't get in too much trouble for saying this. What 3GPP is looking at is sort of two different ways to do the authentication of the client to the WLAN.
Yeah.
They're either looking at using 802.1x with the HLR, HSS back in the core, right? Just a EAP-AK, EAP-SIM back there, which makes sense to me and could be hotspot 2.0 triggered, which I would certainly like to see. Or they're looking at the sort of DPSK, dynamic pre-shared solution, where there's a value on the ENB, which is unique to every ENB, called the KENB. They're thinking about doing an algorithm or doing a pseudo-random generation of a PSK off of the KENB.
Push it.
And then when the client registers initially to the LTE network, the ENB would send it a specific SSID to associate to and this DPSK to use to authenticate. We're not too keen on that, quite honestly. We would much rather, instead of the ENB sending down a specific SSID in this DPSK, we'd rather that the ENB actually just say, here is the PLMN, the mobile country code, mobile network code that I want to use for LWA. Populate that to the client during the LTE registration. And then anybody who wants to do LWA on their WLAN could just advertise that PLMN using Hotspot 2.0 and ANQP. So that's sort of what we're working on.
Yeah, I think that's the biggest thought in my mind. I'm watching that is what happens when you don't provide that service on your wireless LAN. Second of all, to your point where you were saying that you don't want this broadcast over your network. You already have your allocations for capacity, your allocations for users, and all that. Everything else that's involved. What happens when I'm at a hospital and I walk in as a patient, or as a visitor, and I start utilizing the infrastructure to do all my whatever it is that I'm doing on my phone. There's that component of it. I wonder if it opens up the opportunity for like a neutral host environment where
That's right, yeah,
maybe T-Mobile or Verizon comes up to you and says, you know what, we'll pay you, pennies on the dollar or whatever it is in order to.
Well, it's like Wi-Fi calling. The same thing applies for Wi-Fi
same
calling.
thing, yeah.
Right.
But
exactly.
I think the part that I'm trying to figure out is how does it know? How does it know that this device, how is it aware that I'm on a network where it can send that information in the downstream? I can talk up to LTE and say that's great, but how does it know, okay, you're on a approved wireless network where here's your token or whatever it is so that you can communicate on it?
Well, and I think that's where kind of going back to a Hotspot 2.0 based solution with 802.1x as the auth kind of ties it all together.
Well, and who's responsible for that also? Because then is it the Wi-Fi provider that's responsible for handling some of that authentication, or does it all go back to the S gateway?
We just need to run it all in channel 14 and just allocate channel 14 for.
It'll all be good if we put on channel 14.
One channel.
But I think to your point, if again, with an enterprise or a neutral host solution, if we did this with HS2O, then it's up to the administrator of that enterprise WLAN to say, yes, you are, okay, I've signed an agreement with T-Mobile, I'm going to start advertising your PLMN, in my network.
That seems like a very.
But I don't have to deploy another SSID, right? Because the way that some of these people are looking at this, it's like, okay, every MNO is going to need their own SSID. It's like, whoa, hey guys, we've been trying to get away from that for a while here.
Yeah. So and then I mean you brought up a point where you talk about the eNode B having integrated functionality, having an AP built into it, having a Wi-Fi AP built into it. Why not the other way? Why not have a Ruckus AP with the LTE functionality built into it?
That sounds like a good idea.
I'm just curious. I mean, is that something?
It sounds logical to me. So, and it kind of comes back to Sam's question earlier about private LTE as well, which
Private
I think I'm
LTE,
going to jump. I've got a slide here on the FCC public notice. FCC did a bit called public notice back in the May timeframe, asked for input on LTE-U and LAA. Everybody and their brother made a filing in regards to this. Just some highlights. Not a lot of consensus, as you can imagine. There's sort of two sides, and they each had their opinions. They asked for LTE-U and LAA input. We took the opportunity to say, hey, you guys need to be tracking this LWA thing as well. And that was also when Qualcomm announced the multi-fire proposal. So, so OET, which is the Office of Engineering and Technology, came back with a follow-up letter to the LTE Forum, which is doing LTE-U. This was early August was when that letter came out. And then OET said, hey, we're now tracking 4 discrete proposals, LTE-U, LAA, LWA, and multi-fire, which we were very happy to hear them say. And they were specifically asking for some information from the LTE Forum in regards to why do we need this LTE-U US-only technology when LAA is going to be coming out of 3GPP in a matter of months at this point, and it'll be a global standard. And LTE Forum did reply. I don't feel like they ever really addressed that specific question. Just wanted to update you on that. I know I think Keith and Lee both commenting that you guys, it's helpful to be tracking like the FCC blog. I try to track these filings on 15105 which is the LTE and unlicensed stuff. The other one that's of interest to us is 3.5. What's the FCC is doing in 3.5, which if I get to it, I have a slide or two on that. I'm going to actually jump ahead. So the next big thing that happened at the end of August, about a month ago, was a workshop over in Beijing. I'm not sure who the handsome guy at the bottom is, but really, again, in my opinion, FCC, when they put out that public notice, said, hey, 3GPP, what's going on between you and IEEE and you and WFA? What coordination is happening between the LTE people and the quote-unquote Wi-Fi people? And not long after that, 3GPP said, we're going to do an LAA workshop in Beijing, and invited IEEE, WFA, WBA, FCC, Ofcom, and a few others to come and provide, or to have an information exchange on LAA. So a bunch of people showed up in Beijing a month ago, and IEEE, WFA, WBA, the cable industry, and the automotive industry actually all had contributions at that workshop. At a very high level, I would say it was actually a very cordial meeting. I think it was quite constructive, and Paul Nikolic, who's the chair of the 802 committee within IEEE, was there. Rich Kennedy from the 802.11 committee was there. Greg Ennis from Wi-Fi Alliance was there. I happened to be asked to represent the Wireless Broadband Alliance there. So, it was good. It was sort of everybody kind of understanding each other's processes and how things worked, and it was a good conversation. WBA, which I was speaking for, made the point that I know we're here for an LAA workshop, but LWA just seems to be left out of this conversation right now.
It has been. And I've tried to keep up with it. I haven't seen it, in a lot of the different, and I'm not the only person in the world, and I can't read every article that's out there, but it's fascinating that something that seems this beneficial to the Wi-Fi space doesn't have the same press coverage that the other guys do.
It's starting to get there. It's happening now, but it has, again, it has been left out of the conversation.
And I just tweeted that, it is funny, the irony, how we're talking about how LWA can be used to actually monetize your wireless LAN if you open it up as a neutral host to someone that's coming in as a carrier. So
yeah. So there's some agreements made regarding review of the LAA spec. I mentioned it's going to be completed in March. They're actually trying to freeze the spec in the December timeframe. And so at that point, the 3GPP RAN chair agreed to forward, the spec as it exists, or the draft spec out to, IEEE, WFA, WBA, et cetera, for a review period. And then hopefully that'll get taken into account in the final spec. I just really want to quickly touch on 3.5. So if you don't know what's going on with 3.5, when you have some time, read up on it. There was a really good article that showed up on RCR Wireless week before last, if I remember correctly. And I think it was an attorney or somebody. He just did an overview of what's happening in 3.5. It was one of the best write-ups that I've seen. So FCC is really trying to shake things up with 3.5, and I commend them on this. So you can see, one of the commissioner's statement here, we're trying to blur the lines between licensed and unlicensed. So, the future is definitely about spectrum sharing, all the things I've just been talking about, how can the LTE and Wi-Fi side sort of share unlicensed spectrum. 5G, if you will, I feel like it's kind of like the election. It's much too early to start really thinking about it all that seriously, but there's almost no doubt that 5G will blend licensed and unlicensed access. So, it's going to happen. So the idea here with 3.5 specifically is, you've got these incumbent military users, military radar, mostly naval radar. We've got to protect them, so they always sort of, get priority access to the band. But then there's going to be priority access, or PALs, that will be available basically for, it's 3-year terms. You can buy a PAL license to 10 megahertz chunks of this. It's 150 meg total band in 3.5. And then what doesn't get bought up during the PAL auctions will be available for what's called general authorized access, which looks a lot like just unlicensed usage, except for it's all going to be coordinated by these centralized databases called Spectrum Access Systems, or SASs, right? So there's a lot of work going on around this, and back to your point, Sam, you know, GAA use for like indoor corporates certainly would be an option. So you know, 70, 80 megahertz of dedicated spectrum that if you get the GAA license for your location, and these are kind of census tracts, so they're very small areas that these licenses are going to be available for. You know, you could use that within your building potentially for sort of private LTE. So, 3.5. So that leads into a conversation about, you know, what are the best bands for the technologies? You know, 5 gigahertz, been using it for a little while with Wi-Fi. Fair amount of devices there. 11AC is only going to be there. So, you know, Wi-Fi obviously probably going to be there. LWA kind of makes sense. 3.5, yeah, it's greenfield. We're going to need a whole new generation of equipment to do these 5 gigahertz LTE radios. You know, maybe 3.5 is the right place for that. And Google has made that point in one of their blogs not too long ago. So